Welcome back, students, to today's lesson. We are continuing and looking at the types of soils. As we know, in Jamaica, we have basically 4 main types of soils, and they are sandy types of soil, silt, loam, and clay. They can vary based upon their coarseness or their pore structure or size, particle size. Clay has the smallest size particles by nature. Sand has the largest. Silt and loam, medium. The major components of soils will be discussed right now. Soil is composed mainly of mineral matter, and this mineral matter takes about 45% of the soil aggregate. And organic matter accounts for 5%, while the other non-solid 50% is taken up by water and air. And it is interchangeable based upon the conditions that we are presently experiencing, whether a dry condition or rainy conditions. If we are experiencing heavy rainfall, you will have more water in the soil and less air particles. Referring to a dry area, you would have more airspace and less water. Let us look at the chemical properties of some major types of soils. The classification of soil types is based upon the properties of the different mineral particles or the parent material from which they are formed or they are derived. Clay types of soils have more percentage of clay than any other content material. Silty soils would have a greater percentage of silt compared to other mixtures. And sandy type of soil will have more sand in terms of percentage compared to other types of soil. And loam is an equal distribution of clay, silt, and sand. Physical properties. Physical properties depends on the feel of the soil. Physical property of the soil refers to the texture and also the structure. It refers to the arrangement of soil particles. If you have clay particles and you wet them, the feel of it will be soft and sticky compared to sandy soils, which are very coarse in grain by nature, and they are very hard to put apart, to squeeze together. If we look at clay soils based upon the stickiness and the adhesiveness of the material when it is wet, that is one of the reasons why it is used in the pottery industry, and it is also used to make some of the wares that we have, the dinnerwares and the crockeries that are found in our kitchens. There are a number of factors that will affect aggregate formation or soil formation, and we looked at climate as one. If the temperature is too cold or the temperature is too hot, soil organisms, both micro and macroorganisms, will fail to carry out their duties. Soil organisms, if it is too cold, they will be unable to operate, and also plants that are too cold will not grow. The temperature can activate the growth of new plants. If it is warm, it will cause seeds to germinate, as temperature directly, if it is warm, it can go between 28 to 30 degrees in the soil. It will increase the growth rate by which seeds germinate into new seedlings. Tillage also can be affected if it is too cold, because the land would have been frozen. Thus, no implements will be able to penetrate the soil comfortably. It also reduces the activities of certain organisms. So the earthworms and the slugs, these organisms will be unable to move down into soils that are very dry and very hot by the nature of their composition of their body. They are very soft in nature, so they are most suitable for working under conditions that are cold or cool and the soil is moist. Let us look at soil porosity and aeration. When we talk about porosity or aeration, we're talking about the percentage of pore space in a lump of soil that is not occupied by solid particles. So if we should have a handful of soil and we squeeze it together, the unoccupied portion there would have been the pore space. So if you put water through that soil, if you have a container with some soils and you pour water, that's air that is drained down, that becomes the porosity of the soil. So sandy type of soil, water will drain through freely compared to clay soils. Water will tend to settle because it is very compact. The soil particles are packed closely together, thus forming a very solid surface. As farmers now, we can look at the benefits of comparing both soils. If you are a rice farmer, it would have been, or a fish farmer, it would have been ideal to have a clay type of soil because this soil is very compact and it stores water readily. Unlike a soil that is sandy, which water allows to penetrate or pass through easily, you will tend to plant peanut on these types of soil and carrot and some vegetables that is easily plucked from the soil. As we continue looking at soil porosity and soil aeration, we say soil porosity improves root penetration as plant roots are now able to penetrate into areas that are less difficult to grow. By so doing, new roots can develop into areas that were created by the actions of the soil organisms as mentioned before, such as the earthworms, slugs, or wood lice. Air for plant and animal respiration is drawn into the soil through these channels that have been created, thus improving the rate of respiration that takes place for these organisms, and by so doing, it will also benefit the soil. Soluble soil nutrients can be easily dispersed when the soil is fully aerated, as the nutrients that is applied to the soil will be equally dispersed. Now let us look at soil temperature and soil organism. Soil temperature affects soil macroorganisms as well as soil microbial activity. The soil temperature is best suited for plants at about 28 to 30 degrees Celsius. The roots of seedlings are destroyed in high soil temperatures. So temperatures exceeding 35 degrees and over will cause deformities to roots and also will dry out these roots. Germination of seeds into seedlings will be increased when you have warm temperatures, but excess heat will also cause these young plants to die. When we have excess temperature here, going over 35 degrees Celsius, we start to having soil caking and crusting, as in silty types of soil that is found basically in the areas of Clarendon. In cooler countries where you have glacial actions of ice over time, the ice will affect the soils as it will cause the soil to freeze over. When the soil freezes over, it will become very difficult for soils to be plowed, and specific implements would have to be used, drawn by heavy-duty tractors. Soil nutrients continued. Presently, there are 17 essential nutrients for plant growth and development, 14 of which are supplied directly by the elements and 3 coming from the air. These 3 are hydrogen, oxygen, and carbon. Of these 17 nutrients, 9 of them are major or macronutrients. The first 3, nitrogen, phosphorus, and potassium, are always commonly referred to as N, P, and K by their formula. N for nitrogen, P for phosphorus, and K for potassium. The nitrogen will supply plants with nutrients that will provide green leaves, that lush green color. Phosphorus is for good root development, and potassium is for good flowering and fruit set. There are other secondary nutrients that are present, such as calcium, magnesium, sulfur, carbon, hydrogen, and oxygen. If we look here, we can look at a healthy corn leaf at the top of the diagram. Then we can look by the deficiencies of certain primary or macronutrients. If you look carefully, you can look at the color coding on the edge of the leaves. You will see a purple color for phosphorus deficiency and yellowish brownish color for a deficiency of potassium, while the yellowing of the leaf is normal for nitrogen deficiency. There are 8 minor or trace nutrients, also referred to as micronutrients. Though they are referred to as minor nutrients, they are still very important. They are only required in small quantities, but they are equally important as the macronutrients. These 8 micronutrients include iron, copper, zinc, manganese, cobalt, molybdenum, chlorine, and boron. If you look closely at the screen, you will look at some iron deficiency, and these would have been shown by the yellowish of the leaves. And if you look closely, unlike for nitrogen deficiency where the entire leaf yellows, only certain sections of the leaf is yellow when you have an iron deficiency, and sometimes both are confused. So we must be able to identify them separately so we can make the correct diagnosis. The other diagram to the right is a calcium deficiency, and it shows yellowish and brownish margins at the edges of the leaves. Now this brings us today to the close of today's presentation, and by now you would have understood a number of things that have been brought to the fore. You would look at soil profile, soil horizons, and soil fertility, and also the formation of soil. So we started looking at the formation of soils, and a quick look back will show that soils were formed through the process of weathering, and as we say, weathering was the breakdown or the decay of rock fragments to form soil. There were 3 types of weathering that were listed. Can we remember or recall any of them? Yes, you are correct. We have mechanical weathering or physical weathering, chemical weathering, and biological weathering. Thank you. If we look at or recall the soil horizons or soil profiles that were examined or looked across, we would have examined and looked at the O horizon, which I'd have the leaflet up there, and the A horizon, the topsoil, the B horizon, the subsoil, and the C horizon going down into the parent material or parent rock. It was also good to note that we came across some micronutrients as well as macronutrients. The macronutrients were the major nutrients that our plants require in greatest abundance. The 3 primary nutrients in this case would have been what? Nitrogen, as we recall, for growth of new leaves, phosphorus for proper or good root development, and potassium for fruit set or bearing of new fruits. There are other essential secondary nutrients or macronutrients such as calcium, as we remembered, magnesium, sulfur, carbon, hydrogen, and oxygen. All are important. Not to be left out, as we said, are the micronutrients. And as you could recall, we say they play an important role just as the macronutrients, and these would have been 8 of the 17 essential nutrients listed. They are, can you remember? Yes, iron, copper, zinc, manganese, cobalt, molybdenum, chlorine, and boron. Thank you for being so attentive for today's lesson.